As we likely already know by now, a polynomial is going to be a collection of terms that have constants and variables. And these terms are going to be combined with addition or subtraction, and the variables have to have integer exponents that are non-negative and all those good things. So an example of a polynomial that we may have studied recently would be like x squared and then plus 3x minus 5. You have a collection of terms. You have variables and constants. The variables exponents are non-negative integers and all those good things. And one of our common things that we do a lot of times with polynomials is we evaluate them at a certain place. So for instance, you might evaluate this when x equals 2, for example. But what if we wanted to evaluate this polynomial for a lot of different x values and look at where all of those input values went? When we evaluated it at 3 and 4 and 5, what were the y values that came out of this polynomial? Well, when you start talking about plugging a large set of numbers in and getting a large set of numbers out, then you're talking about a function actually. And so what we can do is we can consider this as a function. And the way that happens is we'll set this equal to what we'll typically call f of x. And then here's how this works. It works like any function. You have one set of input values, and these are going to be x's that we're going to plug into the function, into the polynomial, and this is what we call our domain. And then when we plug in that x value, we'll get a new answer out. This will be our y value, which will be a part of the range. And what the polynomial does is it's the mechanism that takes your number from the domain and sends it to the range. So let's do an example here. If you wanted to do f of 2, well, what that means is you're going to take out all these x's and you're going to plug in 2 in its place. So we'd have, for instance, 2 squared plus 3 times 2 minus 5. So minus 5. 2 squared is 4, 3 times 2 is 6, so 4 plus 6 makes 10, and 10 minus 5 makes 5. So what we just discovered is if we evaluate the polynomial at 2, which we've done for a long time now, we're familiar with that idea, our output would be 5. Well, you could now turn back around and evaluate this polynomial at 3, or at 4, or at 10, or negative 8, or wherever. And so in my diagram here, in my picture here, 2 would have been in the domain, and f of x would have sent that x value over to 5 in the range. And so if you have a different polynomial function, it'll map these domain elements to different places. And so it's very similar. We're not changing a lot. Don't think that we're dramatically changing what we know about polynomials. All we're doing really is just keeping a better track of the input values and the output values when we're evaluating this for a lot of different x values. And we'll also have to remember to use this function notation, this f of x notation, when you're considering a polynomial as a function. So let's wrap up this video with one last example. Let's say our function, our polynomial function, was 10x to the third minus 20x plus 6. So if you're going to evaluate a function, which is a very common question that's often asked, what we're going to do is we'll take out all of the x's that we have in our function and replace them with, in our case, negative 1. So we'll have 10 times negative 1 to the third minus 20 times negative 1 plus 6. Negative 1 to the third is negative 1. Negative 1 times 10 makes negative 10. Negative 20 times negative 1 makes plus 20, and plus 6, of course. Clean that algebra up a little bit. Negative 10 and 20 make 10. 10 and 6 makes 16. So we've evaluated this function at negative 1, and you could evaluate it at a lot more places as well, but I think we'll stop right there for this video.